Imagine you are in a car, and you press the accelerator. The car goes faster. You press it more, and it goes faster still. It seems logical that if you had enough fuel and a powerful enough engine, you could eventually reach any speed you want, even a speed that would let you cross the vast emptiness of space to another star within a human lifetime. This common-sense idea is how we experience the world every day. But the universe, it turns out, does not play by these rules. There is a fundamental speed limit, a universal rule that nothing can break. This rule is not a sign on a cosmic highway, it is woven into the very fabric of reality itself. That speed limit is the speed of light. In a vacuum, light travels at an astonishing 300,000 kilometers per second. To put that into perspective, at that speed, you could travel around the entire Earth 7.5 times in just 1 second. This cosmic speed limit is the cornerstone of Albert Einstein's theory of special relativity. Before Einstein, scientists like Isaac Newton thought of space and time as absolute and separate stages where events happened. But Einstein revealed something much stranger and more beautiful. He showed that space and time are actually intertwined into a single, four-dimensional fabric called spacetime. The speed of light is not just the speed at which light travels, it is a fundamental constant of the universe, the ultimate speed limit for any object or any information. Think of it as the processor speed of reality. Nothing can happen faster than this. This is not a limitation of our technology, it is a limitation of physics itself. It is the reason why the dream of hopping into a starship and zooming to another galaxy at many times the speed of light, as we see in science fiction, faces a monumental, seemingly impossible barrier. So, why can we not just build a more powerful engine to push a spacecraft past this limit? The answer lies in one of the most famous equations in the world, E=mc². This simple formula tells us that energy and mass are two sides of the same coin. The c in that equation is the speed of light, and because it is such a huge number, squaring it gives an astronomically large number. This means that a tiny amount of mass holds a colossal amount of energy. Now, how does this relate to speed? As an object moves faster and faster, closer to the speed of light, its kinetic energy increases. But because of E=mc², this increase in energy effectively means an increase in mass. This phenomenon is called relativistic mass increase. It means that as you approach the speed of light, your spacecraft becomes heavier and heavier from the perspective of a stationary observer. At 90% of the speed of light, the ship's mass has more than doubled. At 99%, it is 7 times heavier. To push it even faster, you would need exponentially more energy. To reach 100%, the mass would become infinite, and so would the amount of energy required to move it. An infinite amount of energy is something that is impossible to obtain. It is not that our engines are not good enough, it is that the universe actively resists this acceleration. The closer you get to light speed, the more you are pushing against the fundamental laws of reality, and the push needed becomes infinitely large. This is why any object with mass can only ever approach the speed of light, but never reach or exceed it. The strangeness does not stop with infinite mass. Einstein's theory also tells us that space and time are not the rigid, universal constants we perceive in our daily lives. They are relative. This means that for an object moving at very high speeds, time itself begins to slow down, and lengths begin to contract. This is known as time dilation and length contraction. Imagine a pair of twins. One twin stays on Earth, while the other embarks on a journey to a distant star in a spaceship traveling at 90% the speed of light. For the twin on the ship, the trip might feel like it takes only a few years. But when they return to Earth, they would find that their sibling has aged much, much more. Decades or even centuries could have passed on Earth. From the perspective of the traveling twin, the distance to the star would have actually shrunk, allowing them to cover the distance in less time from their point of view. This is not an illusion or a trick of the clock, it is a real physical effect. Space and time themselves warp to enforce the cosmic speed limit. The speed of light remains constant for all observers, no matter how fast they are moving. To make this possible, time and space must be flexible. So, if you were somehow traveling at the speed of light, time would stop completely for you, and the universe would contract to a single point. For a photon of light, its journey across the universe is instantaneous from its own perspective. These effects are measurable and have been confirmed by experiments, proving that the universe is far stranger than our intuition suggests. Science fiction stories are full of clever ideas to get around the lightspeed barrier. The most popular one is the warp drive or hyperspace. The idea is not to move through space faster than light, but to manipulate space itself. Think of it like this: you are on a moving walkway at an airport. You are not walking faster than you normally can, but the walkway itself is moving, carrying you forward at a greater speed. A warp drive would theoretically contract the space in front of a spaceship and expand the space behind it, creating a warp bubble that carries the ship along. Since the ship itself is not moving through the local space inside the bubble, it would not violate the speed of light rule. Another concept is wormholes, often called Einstein-Rosen bridges. These are theoretical tunnels through the fabric of spacetime, creating a shortcut between two distant points. You could enter a wormhole in our solar system and exit near a star system light-years away almost instantly. These ideas are not pure fantasy, they have some basis in Einstein's equations of general relativity. However, the problems are immense. To create a warp bubble or a stable, traversable wormhole, you would need a form of matter with negative energy density, often called exotic matter. We are not even sure if such matter can exist in stable, macroscopic quantities. The energy requirements for these feats of engineering are astronomical, potentially requiring the mass energy of entire planets or stars. For now, and likely for a very long time, these concepts remain in the realm of mathematical possibility, not practical engineering. You might have heard that in the strange world of quantum mechanics, particles can seem to communicate instantly over vast distances, a phenomenon called quantum entanglement. This has led some to wonder if this could be a loophole for faster-than-light communication. However, this is a misunderstanding. While entangled particles are intimately linked, you cannot use them to send a meaningful message or information faster than light. Any attempt to force one particle to send a specific message would require a separate, slower-than-light communication channel to make sense of it. The real hope for faster-than-light travel does not lie in breaking Einstein's rules, but in discovering a deeper theory that supersedes them. Our current understanding of physics is incomplete. General relativity explains the universe on a very large scale: stars, galaxies, and gravity. Quantum mechanics explains the universe on a very small scale: atoms and particles. The two theories are fundamentally incompatible. Physicists are searching for a theory of everything that can unite them, often referred to as quantum gravity. It is within this unknown territory, in realms like string theory or loop quantum gravity, that new possibilities might emerge. Perhaps the constants of nature are not so constant, or maybe there are extra dimensions we can access. This new physics could reveal that the lightspeed barrier is not an absolute wall, but a restriction of our current model, much like how Newtonian physics was superseded by Einstein's. We do not know what we might find. So, what is the real, fundamental reason we will likely never travel faster than light? It is not about engineering. It is not about fuel. It is about causality, the principle that cause must always come before effect. The speed of light is not just the speed of light, it is the speed of causality. It is the maximum speed at which any influence, any information, any cause can travel through the universe to create an effect. If you could travel or send a message faster than light, you could, from a certain point of view, arrive at a destination before you left. You could send a signal back in time. This would create paradoxes that shatter our logical understanding of reality. The most famous is the grandfather paradox. What if you went back in time and prevented your grandfather from meeting your grandmother? You would never be born, so you could not go back in time to stop them. This is a logical inconsistency. The universe, it seems, is built in a way that prevents such paradoxes from happening. The cosmic speed limit enforced by the speed of light is the universe's ultimate defense mechanism to preserve a stable, logical flow of time where causes lead to effects, and not the other way around. While new physics may one day show us how to bend the rules, perhaps by taking cosmic shortcuts, truly breaking the lightspeed barrier would mean breaking causality itself. And that may be the one rule the universe will never allow us to break. For now, the stars remain tantalizingly out of reach, reminding us that the universe is full of wonders, but also of fundamental limits.